Okay, so we're here looking at law of conservation of energy. Okay, we're going to state the law first. Okay, so what is the actual law? So grab a pen. So conservation of energy is where energy cannot be created or destroyed, only transformed, or you could say transferred, depending on whatever word that suits you best. Okay, only transformed. That's basically it. So the idea there is all the energy we had at the start of the universe. So imagine there's the Big Bang, okay, and then there's expansion. The energy that was there is then all the energy we have, okay? So all of this here, all the energy and the whole universe added together adds up to what we had before. And all that's all the different types of energies. So there's an example here with lifting a ball. As you lift a ball, so you have a ball on the ground and it gets lifted up to a certain height, okay? The person's chemical potential energy as they're lifting it, extra long arms here, as they're lifting it up to there, their chemical potential energy from their body goes into increasing the gravitational potential energy and the kinetic energy of the ball. Okay, so that would not happen. You cannot get gravitational potential energy or kinetic energy of the ball unless it had somewhere that it came from. Now, when we look at 3A, there's an example with a skier in a mountain. Describe the energy changes as the skier goes up and down the mountain, up the chairlift to down the slope. So here's our mountain, okay? Here's our chairlift. So as the skier is sitting on the chairlift, the electrical energy from the motor here is providing, so electrical energy is providing gravitational potential energy and kinetic for a bit into the person, and as he gets all the way to the top, the person has gained gravitational potential energy. Where does it originally come from? The electrical energy of the motor. Now that we've got gravitational potential energy, we then ski down the slope. Okay, ski all the way down the slope. So we are losing gravitational potential energy because down here, gravitational potential energy equals 0. So we've lost all that energy. And where does it go into? Well, it goes into kinetic energy of the motion and also the heat and sound of the skis scraping along the snow. Okay, because even at the end, the kinetic might stop, so we actually get rid of all the energy. So that's where the conservation energy comes in. Energy gets transferred from one to another. So that's A. Then in B, example of a light bulb, describe the energy changes, find line and draw a picture. So if we have our light bulb, so electrical energy comes in. So from a cell or from a plug in the wall, okay, that goes in, and then that gets transformed into mostly, depends on the type of bulb, but light, and also a lot of heat, okay. A standard filament bulb will be about 2,500 degrees Celsius, so pretty hot. See an example of a battery. So if we had a battery here, okay, it provides electrical energy. Well, where does that electrical energy come from? Well, it comes from the chemical reaction in here. So chemical potential energy goes into electrical energy. So it's chemical to electrical. And then last one, D, a spacecraft returned to Earth at a high speed. So whereas the spacecraft comes to Earth, okay, so here's your spacecraft coming to Earth. There's a whole lot of flame coming around here, okay. So it's transforming its kinetic energy because it's going at a high speed, and also its gravitational potential energy, and it converts it into heat as it falls. So the kinetic energy is reducing because it's slowing down, gravitational potential energy is reducing because it's falling, and it pretty much goes into heat and sound.